Formal approaches to identify cadet fatigue factors by means of marine navigation simulators. The relevance of the problem. It goes without saying that fatigue indicator, both among cadets and professional navigators, are named to be one of the most significant causes of negative human factor influence in maritime transport. Contemporary studies have been trying to contribute to finding the appropriate way out, focusing mainly on the control of robot modes, while having a navigational watchkeeping practice. However, there are no inquiries embracing direct fatigue indicators of cadets while watchkeeping carried out in real-time mode. Meanwhile, a number of psychological and medical investigations implemented in this field has turned out to be reflecting the heterogeneity of the fatigue manifestation during a certain period of time. These issues are highly likely to be contributing to the significant augmentation of the uncertainty degree in scientific search. The purpose of the work. The purpose of the article is to develop alternative method of cadet fatigue identification during the complex navigation tasks performed on the captain's bridge. The proposed approach is based on circumstantial pieces of evidence. In the course of experimental analysis of the behavior of the cadets navigators, reported to have been carried out for 4 years, several issues had been drawn attention to, such as the posture when working with navigation devices, the reaction rate when performing primary actions, etc. Furthermore, the sensors applying EDS accelerometers in the form of exoback spine have triggered insignificant facilitation of cadet posture identification in space in real-time mode. The particular details must be added to the fact regarding the accomplished automated analysis of microreactions, which enormously simplify the implementation of an individual approach to result in interpretation. Materials and method. In this context, the exoback spine is said to be a dynamic system being defined in accordance to a number of parameters. Data parameters can be represented as system limiters. Considering this approach to exist within the framework of formal research, the most significant components of the system can be named as L, the angle of distortion between adjacent shoulders relative to the exovertebra cadet during the maneuver. M is the complexity of the maneuver. H is the fatigue coefficient at a given time I. Then this set of components could possibly occur in the presence of a circumstantial factor model, representing the initial position of the exoback spine of a cadet in space. It can vividly be observed that within each definite time span, system parameters may vary non-linearly in accordance to having physiological characteristics of the cadet. He is being influenced by a number of external and internal factors. So to be precise, the position of the cadet is engaged in providing a great possibility for an automated system to detect and to deliver the information about what type of navigation device is being operated with. Therefore, when a number of similar situations happen to be, it is reasonable to state that one or another posture deviation has a higher likelihood of being looked at as normal, but only for a short period of time. Suppose that a cadet is performing a maneuver and trying to make use of navigation devices and controls. It goes without saying that he defines for himself the trajectory and sequence of transitions due to his having had experience and acquired behavior patterns in similar situations. So it is worth emphasizing that this is the predominant way of action, plan shaping recognized as being the most productive and valuable one in a particular situation. By all means, there are several other approaches allowing transition paths to be identified and individual sequence of actions to be checked. Notwithstanding, there is another challenge to make a stand against that is noticed to be a problem of comparison and classification of such trajectories. As well as this item, the performance measurement at the early stages of maneuver is to be spoken about. Conducted experiments of Transat's navigational simulator NT-PRO 5000 of Kherson State Marine Academy in Ukraine provided substantial opportunity to come up to the conclusion that skippers' behavior patterns turn out to have been inherited and transformed rarely into new forms. These issues depend mostly on location and weather conditions. It must be noticed that only experienced sailors were involved into the spoken above experiment. So therewith, at the same time, the fatigue factor must be taken into consideration as being the main and significant contributor of any changes in cadet behavior. It is due to the fact that it is completely different from other factors from the point of view of applied strength and degree of influence upon the final result. A proper formal description of events and trajectories of transitions between ships' management facilities and navigation data sources is proposed to apply to the logical event algebra of events. It happens to have approaches which can properly describe the behavior of the cadet under severe conditions. It must be reported that the number of trajectories of carrying out of the typical maneuver actions performed with an aim to determine the cadet behavior model is to be approximately a minimum from 5 to 9. To meet the spoken above requirements, 11 trajectories were taken to be analyzed. In addition, we are to underline that one and the same navigator was chosen to be experimented upon with an issue to perform a typical maneuver action in various locations. Maneuver from modern operation was paid attention. To a certain degree, the figure provides the opportunity to watch the time ranges of work with objects of the trajectory having 2 to 3 levels of deceleration. Graph variables represent an integral index of being ready for the stage maneuver is implementation depending on the identified fatigue. Alpha is a reaction of quick transition to the next element of the trajectory. Beta is an indicator of fatigue during posture curvature. Gamma is an fatigue when the reaction is getting to slow down. The aim of the study is stated to introduce the automated identification process scheme of such types of phenomena that will provide the ability to determine the human factor influence with the help of implicit indicators. These levels would be varied according to the complexity, starting from the least difficult to the most time-consuming ones. L1 is which is the visual perception of the situation. L2 is analysis of current data of navigation devices. L3 is performing maneuvers, steering, machine telegraph, thrusters, navigation signals, etc. L4 is discrepancy with goals, more in computation of maneuvers. In addition, one more situation to be taken into consideration is when there are one or two variables of priority and time range expressed implicitly. In this case, accordingly, it is convenient to use the third axis, allowing to determine exactly all time intervals regarding active trajectory elements. So then graphical deportation will be described by the following geometric system. Experiments and results. To sum up, trying to weigh out, the automated geometric approximation of the trajectory is primarily proposed. This fact certainly grants you the possibility to control the transition speed between its elements in the form of thickness and time in the form of the diameter of the knot. Besides, while the experiment was being performed, there were several cases associated with increased exacerbation of navigation environment. They are written out the negative influence of relevant factors. As a result, frequent returns to previous trajectory elements were noticed to be done, confirming the information about cadet having lost the confidence of his own. Moreover, when the navigation situation is perceived in a much more confident way by a cadet, and when he is perceiving the information with a high degree of reliability, he comprehends the information peculiarities psi parameters in node x have b, x, or phi. Herewith, kx phi indicates that the cadet is aware of phi information on node x, defining a number of knowledge formation rules. Thus, to be more precise, the final goal of x is believed to be carrying out a sequence of action items of trajectory by cadet, while there are a number of conditions. Besides, the passing of the planned route could possibly be expressed with the following intent. So in this case, the definite issue possible to be treated to a successful one is to be said as being without repeated actions towards the elements of trajectory spacings. Besides, it is worth speaking that in some situations to cope with a long trajectory, it would be beneficial to divide it into homogeneous fragments. They are being characterized by high activity of taking decisions, each of which will be separated by a time interval, where m is the number of segments in the global trajectory. At the same time, let's take that the primary fragments of the trajectory are supposed to have been overcome successfully. Consequently, the use of the cadet can be identified and described by conditions in the future, as well as by a specific fragment of trajectories. All these items contribute to increasing the level of information perception in cases where fragments of the trajectory are characterized by the same set of actions in cadet in form of beliefs. Then the create action plan at the time that is being expressed in the information model of behavior Px, where information about the performance of elements Ix phi. Then the create action plan at the time that is being expressed in the information model of behavior Px, where information about the performance of elements Ix phi trajectory is presented as follows. Then the motion of the vessel can be described by the following, where the result variations of the modern trajectory of the operations are able to be described by a variety of general number set of modern situations are defined as where and time can be reported by a sequence of actions in the path of trajectory. The following is considered to be a typical one in the initial stages. Nevertheless, an action plan is being formed at the time. As a rule, the initial plan of the development of the trajectory of actions has been formed. However, all possible factors forming are not taken into consideration. To be precise, exactly these factors will make major contribution towards the supposition of the development of trajectories. We are to mention that it is the information plan of its carrying out that is formed initially being fragmented as delta. Situation identification depends greatly on restrictions such as and supposes as a part of class forming set delta. So hereby, the result of the variable formation of the trajectory can be described as being very different, figure 3a and b. Figure 3, the variable formation of the trajectory. Thus, the experimental study of the modern operation provides a sufficiently high possibility to identify the effectiveness of the action plan, figures 4 to 7. Figure 4, time 7:33:30. When speed is getting to be decreased, reverse small stroke. Fixed pitch right rotation rotor lets you shift the stern towards the berth. Figure 5 times 73630. The vessel is practically moored and located near the berth protection fender. Figure 6 times 73850. Give the head and stern mooring lines. Figure 7 times 746. Tighten up the head and stern mooring lines, make all fast. During the semester, an experiment was conducted having 74 cadets involved in participating and performing the typical operation of vessel mooring and demonstrating various degrees of fatigue. The experiment confirmed the research hypothesis as being evident. This issue can easily be proved by the following scheme observation. Experimental confirmation of the hypothesis. Conclusions on the work. Thus, objective scientific results were obtained. First, the codependency between the navigator's fatigue indices and spatial position of its spine as a dynamic system determined by a number of parameters was investigated, and as a consequence, software identification of navigator posture deviations was proposed to be used. Second, the approaches for shaping the navigator's trajectory of behavior by means of a 3D structured space during the maneuvering of the vessel were proposed. This fact delivered the possibility to take into account his fatigue factor. Third, the final obtained trajectories of the navigator's behavior at the time of critical situations were analyzed. There was obviously a need of using model logic, arranging the possibility to distinguish the classes of temporal fragments of the trajectories. Besides, the factors affecting the performance of individual elements of the trajectory appeared to be determined. This fact allowed us to identify the behavior strategies of navigators on the captain's bridge. All this data is sure to provide the opportunity to describe the effect of individual navigator behavior strategies on the final result. Thank you for attention.